We're streaming live from downtown Mill Bay. It was so wonderful.
It was terrible.
It was awesome.
We had to wear masks.
We didn't have
everywhere.
weird people from other houses coming into our house. So
You know the weird people from the Privet, right?
what? Lies.
So,
That's sacrilege,
so
and I won't put up with
we
it.
had to.
It's gonna give you an F now.
Okay. We had to wear masks literally everywhere, like in the house, if you weren't in your own room, in all the hallways, here, all the hallways in the house, in all class all the time. In crooks when you weren't eating, which makes no sense because like everyone takes their mask off anyway. Base everywhere. It was awful.
It's fantastic.
Do you do like online?
No, it was like
We were one of the very few schools that weren't online. You actually got to be here in person. It was fantastic.
for the time. I guess it was fantastic.
Yeah.
Compared to now,
It was terrible. Okay. Oh, and now the. Oh, whatever. We're gonna give it over.
for grade 10 the next year, it was some rules were still kind of the same for a little bit, but it wasn't as bad. Like, you don't have to see cohorts anymore. I don't think. Yeah, but like contract, and then grade 11 was like regular.
There we go. Okay. Now it's working. Now, we have a lab now. Today is Monday, so you'll be able to start the lab on Wednesday, and you'll finish it up on Friday. I don't know if we'll use up all of Friday. Hopefully, we can take the last half hour out, but we'll see. After we're done this, you'll have some time. Hopefully, this class there will be a pre-lab that you'll need to answer before you go out into the lab. And before I forget, I would like you to make a flow chart of what you need to do before you come into the lab on Wednesday. There's no quiz this week because you're doing all that instead, and essentially the lab has a pre-quiz. A flow chart, because this lab involves a lot of careful measuring with concentration. So you take a certain amount, you add some to it, and then you measure what happens and how fast it takes for the reaction to occur. Then you take another amount, you mix it, and you put it in. If you don't read the question quite right, students end up like giving the exact same concentration because they're not diluting it properly, or they have completely different concentrations. So it's not a difficult lab, but it doesn't entail that you have to be able to read and read carefully. You skip one digit or one line, and then you're not doing the lab properly. Like many labs, actually. Most of my memories of university are desperately afraid that I'm doing the lab wrong and watching everybody around me to make sure I'm on the wrong track. The lab's a little bit like that. So we want you to have a good read over that. Hopefully you've already had a read over it. You can make a flow chart of what you're supposed to do in each step. And the actual reactions are kind of fun, so it's a good lab. So Wednesday and Friday. I'll show you what the pre-quiz questions are in the lab. You'll have them ahead of time. I'm going to go through these different reactions, and we'll do the last little bit, and then I've got some demos to show them. I was going to show the demos first, but I can't find the kettle, so we'll do this first, and then once Ms. Stewart arrives, I'll find out where they are. Reactions, nature of reactions, I was talking about last day, that reactions that are just different do things differently, just like people with different types of legs can run faster or slower. CRISPR's coming. We'll soon be able to give our children the legs or eye color or anything that we want just by adjusting their genes. So maybe this will go away in the future. Now, reactions with bond rearrangements. Or electron transfers. And this is then a property of a reaction, much the same way that someone may be able to look at someone and say, oh, you're going to be particularly good for this sport. I do know a student who came here. They took up rowing. The coaches were all drooling because they're like, their body is perfect for rowing.
That's really weird. I know it's not,
Like,
but it is.
yes, like we want them.
Yeah.
And they didn't really like rowing. They did ODP instead. They did no competitive sports whatsoever their whole time here. You have to have interest as well. If you have a bond rearrangement or electron transfer, something has to physically move around. And so this takes much longer than ionic reactions, where they're just switching partners. Sodium iodide can switch partners with lead nitrate really fast because no electrons are moving around. They just switch partners and boom, the reaction's done. But some reactions, if you have to move entire molecules around, are going to happen a lot slower. Also, if you're neutral, you're going to take a lot longer to react than in ionic reactions. Why? What's special about ionic reactions? What do ions have? Charge. Yeah. We're going to see this in the lab. So this is one of the reactions we're going to do. So what we're going to see, I was going to do it and I was like, no, wait it for the lab. It'll be a little surprising. But both of them will change into a color. You get instant purple and you get slow purple. Now, the ability of your reactants to meet. What is that talking about? Pardon? When they will collide? What type of reactant would you have to make sure that there's enough surface area for? A solid. So we have surface area for solid. Oops, that's not written properly. Whoa. Oh dear. Will you change now? No, it changes. I think the mouse or trackpad is slowly going on my computer. So that's surface area. Or phase considerations. In what type of liquid reaction might you worry about surface area? If you work in a kitchen, you are worried about this. The whole time you're cooking. And I just pray to God that we don't burn down privet when they cook pierogies. Oil. Why would oil be a surface area consideration? It's a liquid. It's all there right away.
It gets everywhere, and then it gets on fire.
Gets on everywhere. It gets on fire. And what might you mix it with that will cause it to get everywhere? Water. Oil is a solid. Not everything can get at it. If the oxygen in the air can get at it faster and have more surface area, it's a bit like a solid now. We could break it up. Throw. There's a TikTok trend I saw of people working in a fast food restaurant, and they have the oil sitting there, and they chuck in a block of ice. That can be like oil everywhere, or it can be an explosion because the oil is much hotter than the water. The water turns to steam. The steam pushes the oil into droplets. You have a ton of surface area. Now you have a flash fire, and it's burning everything.
Or they like put the ice in the thing where they put the fries and just.
Yes, yeah, that goes everywhere. So we need to worry about phase considerations for some things, for immiscible liquids. What does the word immiscible mean? You might have seen it last year. Doesn't mix. No mix. Like oil and water. Now, in terms of reactions, what's fastest versus what's slowest? We have aqueous ions. Then we have gases and liquids. And it's hard, they put them together because it's hard to say which will be faster. Gases move faster, will hit each other with more energy, but they're a little farther apart. Liquids are moving slower, but they're a little bit closer together, so it often works out to a wash. Both gases and liquids can react very quickly. And then the slowest of all, solids. Now, if you can get the surface areas in solids together, you can get them grinded up. This is why one of the recent advancements, 5 years, I guess, maybe 10, is that they've invented a little robot that can go inside a big grain silo, and it just moves around. What is that thing trying to do? Does anybody know? Working the Paris? What?
Create a chemical reaction.
No. It's not supposed to. It's actually trying to prevent one. If the grain isn't going to the silo properly, you stick a farmer in there. They rake things around. They move things around. You also don't want things to be too wet. Things have to be even, and you want to sort of make sure the mass is doing. There's a whole bunch of little jobs to make sure it's all flowing in properly. If you put a farmer in there, number one, they can drown because it's grain. You can actually drown in grain, it turns out. Number two, if there's any sort of spark in an almost empty grain elevator, it's just full of dust. Now, if you take a grain elevator that's full and you throw a match in it, it probably won't even ignite. The surface area isn't high enough. But if you take all that dust floating in the air and you throw in a match, the entire thing explodes because it has all that surface area of dust to actually do. No, the last of the squishy stuff. So, last thing on solids. I didn't put this on the next page, did I? Oh, I did. Never mind. So the molecules and the particles do not move. They're like an 80s action star. Nothing is exposed except the very outside. They keep all their emotions inside so nothing can react with the environment. Liquids and gases. Every molecule is available all at once. Right, damn it. Yep. Oh, it's doing it again.
Is there no command?
Oh, there is. But once it's stuck in this mode, it thinks the mouse is going the whole time. It doesn't listen to commands. This is how our the robots and AI is going to take over the world. Not through any deliberate plan. Pardon?
You should restart your computer.
Yeah.
Probably fix it.
Yeah, no. Yeah, that would take forever. Although, since we are being recorded, I would like to say that I welcome and worship our time-traveling robotic overlords for whenever they get here. And I will gladly help them in their quest. Every molecule is available at once. Gas molecules have a high speed, so that means quick reactions. And liquid has close proximity. I think I mentioned the last day something with molecules, research on who you're more likely to marry once you go off to university. Did I mention that? They did what is the single most important factor that turns out when you're choosing someone at university, especially nowadays with dating apps and swiping, and they're like, what is the single most common factor? And they found out it was geography.
Like where you live? Where you're from?
How close they are to you. It mattered if they were 6 doors down or 3 doors down. You're more likely. Turns out people are just lazy, don't want to walk that far. They'll pick the person that's closest. Yeah, it still works. So if you see someone you really like, just rent the apartment next to them continuously as they move. It's not creepy at all. That's actually, if you change your seat in class, that's actually something you have to worry about. You know how you sit in class and it's like the same seat all year, and then one person comes in one day, sits in the wrong seat, and then everybody has to shift around them? And then the whole class gets disrupted? I did that. I sat in a different spot. Everybody moved around me, and I end up marrying the person who was next to me in chemistry class. So be careful who you're sitting next to. You might end up marrying them. Conversely, I guess if you don't want to marry the people next to you, you might want to move. Ions have the advantages of liquids, their close proximity. But they also have that positive and negative attraction so that they can force themselves together. When sodium iodide separates in a liquid, they're still charged, and so the sodium can go find the nitrate, and the iodide can find the lead, and the lead is +2, and so that's quite attractive, and then they can meet quite quickly. Catalysts and inhibitors. Now, we're going to do catalysts a lot more later, because, it's doing the thing again. Yep. I knew even before it did it. I am so tempted to just restart my computer, except I know it will take so long if I do that. I am not going to IT.
I think IT would think it's a good idea. Yeah. They have it on a shared app for all.
Yeah.
Why don't you look for the catalyst, do the demos while the computer is doing its thing?
At this point, I'm just desperately going to get through it. I'll give you time to work instead of do your lab, and then I'll get the demos going while the computer restarts. A chemical which increases the rate of reaction. Now, what is the opposite of a catalyst? Something that slows a reaction down. Louder? An inhibitor. And if you eat it, it's called a... What did you say? It is in fact a bad idea. Inhibitors, if you eat them, are called poisons. There is a mushroom that grows on Vancouver Island. It's fairly rare, but it acts as an inhibitor for ribosomes. What are ribosomes, though?
They're like essential DNA things going on.
They're essential DNA things. What do ribosomes make?
Protein.
Ribosomes make protein.
Let's go.
So if you eat this particular mushroom, which we know from people's reports tastes quite good.
What?
Because you have some days after you eat it. Because what happens, all your ribosomes stop working. But you still have all your proteins and enzymes and everything that's working right there. They just keep going, chugging along. But they wear out. And as they wear out, they're not getting replaced. As they're not getting replaced, things start to die. As things start to die, all your pain nerves go off to say, something's wrong in this cell. It's dying and it shouldn't. And so you get pain. That's happening to all your cells at the same time. The only way to treat it is to put you into a coma until you die. The treatment in the coma is mostly to spare everybody else the sounds of you screaming the most painful, horrible death that you could have possibly experienced in the entire world. So, do not eat wild mushrooms unless you know exactly what you're doing.
There's another mushroom I heard of.
Oh, yeah. They're also poisonous, and my farm was in the center of the magic mushroom capital in all of Vancouver Island. We used to chase the mushroom pickers out of the field in the morning. I knew someone from the UK. I met him much later. He knew where my farm was. He didn't know the name of the road or the town or anything, but he knew where it was because his parents brought them there all the way from England just to pick magic mushrooms.
Nice. I wish my parents did that.
I did get a nice vest out of it. Anyway, H2O2. We're going to... I would go out and tell all the hippie mushroom pickers to you gotta, I'm 8 years old. You gotta leave now. My dad's coming out. He's good because they would trample all the fields. So you have to go. My dad's gonna come out. He's gonna get really mad, and so they'd slowly go. My dad usually wouldn't come because then they'd go. And one of them left behind a really cool vest. It was shiny green on the inside, but a purple bright corduroy on the outside. I found it. I wore it for years after that. It's lovely. H2O2 is a demo we're going to do. We're going to see that if I take H2O2 very slowly, so slowly you cannot see it happening, it is breaking down into water and oxygen. But if I add a little bit of a catalyst, now the catalyst I'm going to talk about here and put in your notes is liver enzymes. Because there's enzymes that are specifically designed to break down hydrogen peroxide. If this is floating in your body, it's really a bad idea. You have enzymes, it's made as a byproduct in a few reactions. It's broken down right away into water and oxygen, so it's not that toxic. And you can get away the oxygen. It doesn't accumulate anywhere and do something bad. I'm going to use manganese dioxide, which also acts as a catalyst. Dylan, are you okay?
Yeah.
But the enzymes are still there at the end, just like the manganese dioxide will be there at the end. The catalyst doesn't change. Later on, we're going to talk about the energy of the reaction and the activation energy, and we'll find out it's doing it by lowering the amount of energy the reaction needs to do. Last one, as we said, an inhibitor is something that does the opposite. They're also known as poisons. Another word for poison is antibiotic. Antibiotic literally means anti-life. We just have picked a type of anti-life. So say, for example, penicillin attacks cell walls. It attacks the enzymes that make cell walls. You don't make cell walls. So any bacterium that has a cell wall dies due to it. You're safe or relatively safe because it only kills the bacterium. That being said, you have more good bacteria in you than you have human cells. You are more bacteria than you are human. You are killing those off. That can have some health effects, so we don't want to eat it like candy just for fun. But
does it also kill vegetables that you ate?
Vegetables aren't bacteria.
Yeah, but they also have cell walls.
Oh, they're not living and growing. Your teeth and your digestive enzymes will do a lot worse damage to them. Yeah. What? Reduces, obviously.
Come on, do the word thing.
Okay.
Redub, yeah.
I feel like redub almost is right.
No.
It's a little right.
Nope.
And
Right is not right.
I can't fix it. Oh, there we go. I'm going with that.
Let's try it on the very last one. It'll know.
Okay. Almost the last page. Compare and contrast factors affecting the rate of both homogeneous and heterogeneous reactions. What does homogeneous mean? Yes.
No, sorry, I was trying another question.
Oh, yeah, sure. I moved on.
For catalysts,
1 second. There's
for catalysts, do you always write them in the reaction, or do you just
Oh,
leave them
no.
on the side?
I did that here just to show that it was unchanged.
Yeah.
Normally, we actually write it above the arrow because it doesn't matter. It doesn't have to be on either side. However, what we will be doing later on is we will put them into a multi-step reaction. You have to identify them by the fact that they don't change. Yep. Okay. What is a homogeneous reaction? No, you've answered too many, and you did AP last year. Not asking you anymore. Someone else. Then why do you know so much? I'm suspicious.
I was an AP bio.
Oh, and you did. Sure. Okay, go for it. Show off your knowledge. What does homogeneous reaction mean?
A mixture that don't look the same.
It does all look the same. In chemistry, for reactions, it has to do with the phase. So it just means it's the same phase. Technically, it would be a mixture because they are all in different things. This is the Greek root. So you have homogeneous reactions, and you have heterogeneous reactions. You may have seen I think they're the Latin roots, homogeneous and heterogeneous. You could also have cis and trans. Those are the roots in Latin that will go back and forth. I met someone at a Pro-D conference, and she was upset at being referred to as cisgender, so I called her homogender. That made her even more angry. But that's what the root means. Particles are in close proximity. So notice these are gas, gas, aqueous, aqueous, and liquid, liquid. What's missing? Solid, solid. Why is solid, solid not homogeneous?
Hard stuff don't mix.
Hard stuff don't mix. So you have two solids. They're still heterogeneous. Way back in Chemistry 11 and Science 10, you probably called it a mechanical mixture. They're just sort of bolted together. They don't mix unless you grind them down to a fine powder of individual molecules, at which point, congratulations, you created a liquid. So these are rapid reactions, as there are no surface area considerations. We don't include solid-solid in this. Heterogeneous reactions. Reactions are in different phases. There we get solid, liquid, liquid, gas, solid, gas, and liquid, liquid, as long as they are immiscible. Again, no mix. Oil and water. And these are the ones that are affected by surface area. Take two immiscible liquids, shake them up until they're tiny little bubbles. They'll react faster. If you have two solids, grind them down. If you have a solid and a liquid, grind the solid down, and so on and so forth until they react faster and faster and faster. We're going to do zinc and sulfuric acid, so it depends on how fine the solid zinc is. And But if you're trying to burn a log, you know you can't just take a match on a log. You need some tinder or some paper or something with a high amount of surface area to get that fire going. And then you can.
Mythbusters Season 6, Episode 11.
Yeah, it's amazing. You should see it sometime.
44 to 3507. Can we watch it?
Right now.
Once I'm done and I show you some demos, if we have some time, I'll show you that one. They do one of the largest versions of a lab demo I have ever seen in my life. Moving on. Oh, don't worry, we're almost there. Lies. What last word? Splinter or Tinder?
It's going down.
I just got why they named Tinder Tinder. Because it starts a fire.
Starts a flame of passion.
Yeah. I never got that before.
Tinder, I hate. I'm never getting it. If I'm lonely, I'm just gonna be lonely. Like make weird art.
Just so you know, grade 12s, especially if you're a prefix in the house, make sure the juniors who are new are aware they're not allowed to use Tinder here. We did have a student a couple years ago who went on a date with, like, she was in grade 10. He was like some 35-year-old guy from the community. Watch out for the younger ones. They're not that bright. This is reading.
I think you should restart your computer.
Yep, that's bad. Moving on. We're down to, there you go. Oh. Yeah, I definitely have to read, something's going on.
Just going. I had Ribo for a while. Y'all know what Ribo is? It's like an app. It's like make friends. But it's just in their
I gotta have timber stuck in my head for the next one.
Okay, you can start the Hebden. Now, it only goes up, what I handed you only goes up to question 10, but I have digitized a section until we get the textbooks. And I am putting it in now. Let's double check.
This page does go up to 17. I don't know why.
Goes up to what?
17.
Oh, does it? I thought I only photocopied less than that. Anyway, you have Hebden pages 1 to 100 now for the
I'm so excited.
foreseeable future.
Questions 1 to 107.
If you can start your Hebden, and you can also get out your labs if you brought them. Probably didn't. However, there are a couple in the classroom. Lab 18B. If you'd like to read over the lab, I realize it doesn't have the pre-lab questions in it. I thought it did. I'm going to post those today, probably right after this block. Yep. Question?
I like always written down his questions.
Oh, perfect. Yeah. You don't have to write out the whole questions, but I know students like to do it. It makes it sometimes more effective for studying, so you don't have to look it up in a book. So no, it's fine to do. But I don't demand it, because if you read the question and you do the whole, what I'm looking for is your workings. But if that makes it more useful to you, then yes, definitely do.
We have like a 5-minute break before we start working on that.
Are we doing experiments now?
Yeah, I'm just doing demos now. You're just working it. I'm doing demos. If you take 2 minutes to sort of cross your eyes and have a bit of a mental break, it's just,
Alright.
okay. I mean, I think in the last 5 minutes, like 3 people have left to go to the bathroom, so there's mental breaks all the way around. Yeah.
I was very confused when I was doing the video on the how color can be used as a reaction rate.
Yeah.
I was wondering if it was, I just assumed it was like how long it takes for the color to change from one color to another.
Sure.
Is that how it's
That you could measure that, so you could measure the time for the color change. You could do different concentrations, and then if you have like an excess reactant that has a color, you can measure how much is left over. So that's been used at times. But yeah, before the color changes, is a common.
Yeah. Did I snore last night? I fell asleep.
You snore, Marty?
Yeah.
Is he allowed to snore?
Bro, yes. I can show you.
Is he allowed to snore?
It's not quiet. It's just like
Yeah, then you ever snore?
my friend could get sound like people snore on the ground. Yeah, like my friends would be like, because like I was sleeping over at my friend's house, and there were like 4 guys there, and they were like, they thought like me and another guy were in the same bed sleeping, and that both of us were snoring, but it was just me. What Connor? Just go to sleep. Go to sleep forever.
I'm guessing because.
What are we doing now? I need no help. I gotta do 9C. It's really hard.
Repeat that then. Have you seen that?
Yeah. I'm just doing the flow chart.
Who's that?
Linda, some.
Is she also trying to
Already. Yeah. Okay, so I'm doing the right thing. Yeah. That's out of pocket.
Oh, no, it isn't.
Yes, it is.
Please,
But the last one you were
yeah.
just trying to.
And it's very fun.
I would never work there, bro. You wouldn't marry me.
Edmund, phones away.
You're trying us on screen.
Just because I can't see, can't see
How
us.
do you do?
I don't have the. Do you have
Where is?
I have the little
Friends
name.
and benefits.
Don't do that. That's bad.
Where? You are rookie.
I don't know. It's just.
You guys.
How do you write a date? Months. Very good.
I gotta catch up.
What do Canadians do?
I think they do month, day, year. I do like today is so. Like if you're writing it down in number. Yeah. 9, 18, 20.
What Bob? Tiana Jim Bob?
I haven't looked at it.
Who's on 9?
I'm just starting it now.
Bro, come up here, take on, bro. Bro!
But it's actually nasty. The grate had got shot out of it.
I feel like that's enough. That was 35. Even that.
Still, like, even if he was like 20.
20, that's still horrible.
Yeah, even if he was 20.
But 35 is almost unbelievable.
Yeah, it's not. I don't think it is unbelievable. That's the scary part is, and I don't think it is.
But trust me, there are plenty of creepy men who are way too 17-year-olds and 18-year-olds who would go out with 20. Well, breakdown, that's not usually.
Yeah, but she probably, you have to be at least 18 for Tinder. She probably put that you're just 18. He's probably good. She's a great time, so he probably tells you all that. He probably didn't care.
Yeah. This 18-year-old looks really young and
Hey, I
mature
mean,
for age.
he's probably thinking, hey, if she isn't, you know, I can just say, well, her profile said she was
Well, officer. Well, Your Honor,
an officer. She told me she was
the count said it was 18.
Officer,
The guy knew and said that I was 20.
Officer, she told me she was 12. Oh, no,
You wrote them all out.
yeah, I wrote it all out.
That's the problem, Your Officer.
Except like the ones that are multiple cycling, millimeters, and grams per minute.
That's like a multi-layered joke.
Expressing a rough reaction.
Yeah, well,
It's asking if it's an acceptable unit for expressing reactions.
It's a multi-layered. That's a joke with layers like onions. You gotta unpack.
there's just 2 layers. That's it.
Yeah, but it's like more than
It's
most.
layer.
Jokes. It's more than most.
More than
jokes.
most.
see the vision? You're right. Like that's correct. Except it's the second. You know what I'm saying? Divided by 1 month. Big face is 2 months. Okay, so then you just do 0. I'm confused.
Oh, no. Someone noticed that your handout skips pages. Apparently 2 of them or 3 of them got stuck together in the photocopier. But you now have on the Google Classroom the first 100 pages.
Yeah, but it's still goes.
Oh, does the Google Classroom?
It fully goes straight
Yeah, I
to
know.
question 11 of question 17.
Minutes per meter.
No, that makes no sense. Moles per
In
second.
that case,
Right?
Oh no!
Yeah, actually, yeah. Perfect.
Let's do children.
what pages are we missing?
Meters per second. That makes sense, right?
Are you just ignoring it, or did you not know 8 and 9, I think?
It's like
Page
you
8 and 9?
Go to divide
Yeah.
Oh,
by-
moles per liter
Page
per
7.
second.
I didn't,
That,
because obviously I photocopied them from those pages.
that works.
Well, I printed them and then
Grams per liter.
I scanned them from the pages, so the same thing happened in both.
No, not grams per liter.
So 8
Liters
and
per
9.
hour. Yeah. Grams per minute.
That's your titty.
Definitely not.
Yeah, definitely not minutes per meter. But if you think about it, minutes per meter is the same as meters per minute. So,
But it's
So,
change
how are we
in
gonna do like question 10? We've never.
concentration over time.
We never what?
Time. Time on the bottom. Concentration on top.
Yeah, we're not able to do number 10.
okay,
We never learned it.
What's question 10?
Elaborate on.
Yeah, we just did that today.
no, I think you got it just
What?
perfectly fine.
Yeah.
I did.
Whoa.
I did.
Rate of reaction.
That's a you problem. That's an issue.
No, I want to get you to. Explain that. Please say that louder.
I don't know.
Oh wait.
We are block A. I am adding the 2 pictures that were apparently missing on the handout right now.
How are we meant to know when things back?
So, so you have figures for this one.
And I'll fix the handout in the future.
Has 1, so I have to add 1 to
It should be saved now.
the
Okay. Now we need some sulfuric acid.
As part of it.
HCl. No.
Part of that
No.
ratio thing.
There we go.
Typically, you only count like 6 eggs that you're
Mr.
given
Newton in here. Oh.
at the very start.
Oh, we didn't get
Or
Who said that?
I did.
With what question?
I don't know how to like know which one's faster.
Oh, go back and read your notes.
We just went over this.
Yeah, but we just did this in class.
Wait,
We
so
didn't do a single problem.
rate of water production. Okay, 1.3 moles per meter. What is the rate of oxygen gas consumption? Expressed in moles per meter.
Bro, which?
Is it point 67 moles per minute?
That change it?
That might be the answer.
could be. I think we can just guess that.
What did you do? Because if it's 0.6, I don't want to, like, if we need something different, I'm not going to, like, copy it. I'm going to try to figure out how you got there with that. Thanks, bro.
Okay, hopefully this one works. You have to see this one in the few bit. Come on up.
Guys,
Oh, make a wish. That should be.
Make a wish. go. Come on up. Come on.
So it should be the same thing.
Okay, this is potassium chlorate with regular table sugar. So, potassium chloride is KCO4, 3. Oh, we are going to do it again. That's with regular table sugar. The table sugar that looks like that. This is with icing sugar. What's the difference between icing sugar and regular sugar? More sugar. I don't know. There's a difference. Also, the chemistry. Oh my God, there's a difference. Much faster. So that one, we increase the stress. Okay, you like it?
I look directly at him. Always looking for you. Always look directly at the sun.
Like, bro, you guys are smart for staying in here, though.
Always look directly at the sun.
You know it. Okay, can we go back to work?
No, I'm not James. James, come here. I need your help.
Why do you need my help?
Because you're an AP, bro. Rank the following 3 reactions and compare their respective reactions and tasks. How do you know which one's faster? Apparently you taught this one.
Do not above me. This is very hot, almost boiling water.
It doesn't look hot.
Water that's about to boil looks exactly the same as regular
Can I
water.
drink it?
Look at
I'd
your
rather
look
you
at your
hold
Right
it.
now, go put your hand in it.
Ain't no way.
Go put your hand in it.
Martin, do it.
I'm not even. It's cold.
He's not getting water.
It's steaming. I can see the steam.
There's no steam.
I can see
You're
it.
tripping. You're tripping balls. It's so cold and steamy.
No.
What did he say?
James doesn't know how to do it.
Does anybody know how to do it? Does anybody know how to do 9? Push.
No, what
How
I'm
do you
saying.
like the bonds and stuff, so double bonds get
Pressure.
stronger, so
Yeah.
it's breaking apart the other bonds.
Can anyone make a hydrogen bond?
So it goes in order. It goes C, A, B. Is that the order that you're going when I for it? Because they're
But
thirsty
it's just
and
like,
they
you have to look at all the bonds,
they
and
get
then
all
like,
those.
if
Yeah,
more
that's
double
very,
bonds,
very
then it'll
different.
take longer.
It's a double order.
I'm gonna do the same one.
I don't know if it's right. Seem right.
What's the atmosphere problem?
This
It's like 2 to 1.
is a glow light.
Yeah.
And I want to
You'll be able to look up the answers later. But I'm not just going to tell you the answer.
Yeah, but not right now.
I'm just going to give you an idea if your theory is on the right track.
Yeah, but like hydrogen bonds are like easy bonds to.
But at the same time, you also have a double bond of oxygen.
Yeah, but it stays double bonded. Like the bond isn't breaking when you have the debate.
Ooh. That's what I like to hear. Spirited debate.
You think this is why I'm not sure.
Do we not have a consensus going on? This happens when we go right again. Hmm? Because we don't have, it turns out, any powder funnels. We only have like liquid funnels. And they're different. So I use one of the liquid funnels. It will
I was right up
it'll get stuck because it's made for liquid, so it's very thin. And so the powder just gets stuck in the liquid funnel. It's not wide enough.
Bro, why is it, Mr. Yukon, why is there like 6 questions in this?
I posted the missing pages onto the same thing on the Google Classroom. It just was skipped, and apparently it was also skipped, probably because I used the same thing to print them, on the sheet on the Google Classroom. So I just quickly took some pictures just now and posted them. Okay, we can already see a difference in light level. So we have our demonstration that with the big bright board behind me. This is in near boiling water for your glow stick, and this is in near freezing water with ice cubes. And is it a property just of the glow sticks? Well, you can test that out by switching them. This is what you do if you're testing to see if a cancer cure works. You divide the group in half, you have a control, you have a treatment group, and if the treatment group starts doing really well, you just switch them all so that they stop doing well and they go to the control, and the control becomes a treatment, and you see if they affect swaps.
And if it ends up working, the CIA pays you to visit, and you get and you commit suicide by 4 gunshots to the back of the head.
No, that's Russia.
No, that's United.
We only do
that's
two here.
We know that it would be the insurance companies, not the CIA.
But they're all connected. Think about it.
Now they're becoming the same temperature. Turn the lights back on for that one for zinc. So I've got zinc, not quite powder, but ground up far more finely. And zinc in chunks, small chunks, but chunks. Zinc, as you may recall from last year, reacts, I don't want that one. Let's try 1 molar first. Reacts with hydrochloric acid. What does it react to produce with hydrochloric acid?
Oh, what?
Okay, that wasn't good, and I'm really glad I was wearing my goggles.
It spilled on me.
Did
You're
it?
gonna die.
Yeah.
Yeah, go wash your hands. Can you watch that for bubbles?
Oh my god.
At least it was 0.1 molar.
It's kind of a boring class here.
Imagine that was like the high pouch.
flame.
Oh wait, 10 seconds. No, Fish, you should have ran out into the lab and used the shower. Like, I have stuff on me. Hold the shower.
For this one, it's yeah.
6 is so near.
With
You burning away.
Yeah, but my skin is burning away, and there's worms under there. I need to get them out.
Is it bubbling though?
There's bugs under my skin. I need to free them, but I can't breathe. Guys, your bones are wet, guys.
Eve, go put your hand in it.
Bro, there's more bubbles in the chunky one. Bro, my calves were like so bad, bro. They're so tight.
You're like,
Bro.
stretch them. Yeah, I'll stretch it out for you right now. Yeah, they make that look cool. Oh yeah.
That was horrendously exciting. Has it actually bubbled yet? All of that.
The chunky one's bubbling more.
We actually have a big bubble that came up down there.
Just the lid in it.
I also didn't want that much because I wanted to add a little bit. So, I need that top out of there. This is just so disappointing on so many levels. Oh! The glow sticks have finally switched their colors at least. I've got to also decontaminate this entire space. So I'm going to just jump straight to the 6 molar. If this explodes, I don't know what happened. Like that one was almost under pressure. I don't know what happened to that one because that one just went boom. That should not have happened.
I hope not.
This one is 6 molar. If this one explodes, I will run screaming out of here. Because this is actually quite concentrated. It's not coming up fast enough. Oh, I wish something would happen that would come up faster. There we go.
Did you make the like the palm?
Yeah, my gloves left as well. My gloves left as well. It's also not showing what I expected it to show. The fine powder is sitting so well on the bottom that it's actually covering itself and providing less surface area, where these ones have little gaps where the solution can get through. I should have gotten a fine powder. Yeah. That is. These formed a gas so quick, you can see it happening. They formed a gas, they almost float, and then the gas surrounds them and stops the acid from touching them. So they reacted so quickly that they created a condition that stops it from reacting. Which I guess shows the point, sort of an exception that shows the rule. Whereas that is coming off. Does anybody know what gas comes off when you add a metal to acid?
Hydrogen.
Yeah, it should make a little pop. Now I normally light that. What time is it? There. What time does this class end? Yeah, I probably have to spend a few minutes decontaminating. We'll see. Who goes to pop?
Well, I had no breakfast. I still got the breakfast. I need like double.
It's the thing about being weird. So you go to
doesn't feel good. I think I might just be like tricking myself. Because it didn't like get on my hand.
Okay, if it does pop, this is the only chance because it probably won't do it more than once. So that's how we know it was hydrogen gas. I will do the last one before I finish cleaning it up.
Explosion of what we did with the balloons. Yeah.
Yeah.
That was like a mini one.
Can you do that again?
Nope.
Blew up your
This is hydrogen peroxide. It is 30%. If this blew up on me, I would also run screaming. Because this will turn your skin white, hard, and have it fall off. It is very, very slowly giving off oxygen and water, which you can't see. It happens that slowly. But if you add a catalyst, now I don't have liver enzymes, but I have manganese dioxide, which is almost as good. You can get a gas formula. To prove that the gas is there, again, you light it. Only in this case,
It's not there.
if you can reignite a splint, what a gas is it?
Oxygen.
Oxygen. So this is, I've used it all up in the last one. So this is oxygen gas, H2O2 goes to oxygen gas and water. It does not happen on its own. This is also known as rocket fuel because it gives off oxygen gas. This is how you carry oxygen into space. You don't have oxygen in space. You just take a fuel of H2O2 and then add a catalyst at the right moment, and then you have lots of oxygen for your fuel. Okay, now I'm going to clean up as you work. And maybe go and wash all the acid off of my body and contemplate my life.
So why do you guys being in the classes?
It's got like 4,000 like charge positive reviews and then like not saying like positive. You know what I'm saying? So I didn't go on it, go faster. And then it's not from the cigarette. So we actually first give a cigarette. Oh, it's not the lowest it's gone down to. Oh my god! I checked out the like deal.
price check.
I can just.
Dang.
I made like
And then it's A, C, no, and then it's C, A. C is the second one. I don't know.
yes, because
like
combustion
a combustion.
is taking gas. The gas is faster than. I don't know. What is the stuff on top? Is it water? It's not.
Oh, just baking soda. Baking soda acts as both an acid and a base, so it'll neutralize anything that's on here. And make sure it's safe for the math teacher who comes in. Because if I said, oh hey, watch out for the acid on the table, that would probably be bad. Watch out for the acid on the table? No.
I don't know if my eye actually hurts or if I'm like fooling myself.
I think I'm just paranoid.
I mean, I watched that. Look,
I don't want to sit there forever.
but
I've done it before.
You
It's
can
not
go
fun.
right now and go have a shot.
I think I'm good. But I don't know.
Yeah, go have a shower.
To take a shower.
Yeah, go have a shower. Even if it's just mental in your head, the shower will keep you.
I want
What? No.
I don't even care. Oh no, I had a shower.
I'm going to insist you go wash your face.
Okay.
Go wash your face.
Government mandated.
Because if you don't think it hit you, but then it turns out it did, I wouldn't want anything to happen.
Does he even have to make it stop it?
If you get, it's like 100.
This one is like, I don't know, aqueous. And these two are like
They were just going to
liquid and gas.
Go wash your face. I will come back and see you. Right now.
Oh, really? Okay. These are liquid and gas.
We're never gonna.
And then I can get liquid bacon.
Do they?
Oh, yeah.
Would the number of bond rearrangements make a difference?
No, but I thought she was still. No, she's graduating us. She stayed with us for like.
You have to hold a party
Oh,
and have
she's like
5 people organizing it versus 100 people organizing it. Is it? I mean, the surface area is the same, but you have more moving parts. Sorry, a party with 5 people attending and a party with 100 people attending. How much longer is it going to take to set up one than the other? Even if they're both in the same venue. I am running to clean this up, so I'm going to ask your next slide teacher.
But for you, it's worse. There's less guys. Yeah. Yeah, when I'm not sick. It's like the parts I could sing with my voice being all raspy was good. But it's when it got higher long, I was like, then it started like cracking stuff in. Okay. Yeah.
Cause I'm like worried, I'm like, taking a little fun, but I think it'd be fun, but I haven't had a focus on what I'm doing.
So what's the reason? I didn't understand. Because it's more. Oh, more. I heard molar. Smaller. Smaller. Oh.
Smaller, no, smaller item, or smaller molecule.
Makes sense.
Two small things have less bonds they have to do with each other. Less bonds have to
Oh
form.
yeah. That means less energy required.
And just less time.
What I think happened is that it formed hydrogen around each particle and it stopped reacting. I showed them that. It's like, this is the exception that we proved it really reacting so fast it stopped. So we used to have like powder. But if we don't, I'll do the same thing.
You won't.
We're here, right? Everybody?
I believe so.
Yeah?
He sent you an email?
Okay. When?
I think I'm good.
You wash your face? Feel better?
Feel better.
Excellent. I'm going to go have a full shower. But then again, I was right in front of it.